Hi guys, hope you are enjoying your study as well as your college life. Today we'll continue our lecture on sequence and series. So today what we are going to study. On the very first class we discussed about monotonically increasing and decreasing sequence. Yesterday we learned about when a convergent sequence or when a bounded sequence will be convergent or divergent. In the similar fashion, we'll study when will be a monotonically increasing or decreasing sequence will be convergent or divergent. Okay, I hope you remember what is monotonically increasing sequence. If my sequence is monotonically increasing, that means a1 is less than equal to a2, less than equal to a3, like this. You remember, if it is monotonically decreasing, that means a1 is greater than equal to a2, greater than equal to a3, like this. So instead of writing in this form, you will be happy if I will show in this in the form of diagram. Okay. So suppose this is my a1, this is my a1. As it is monotonically increasing, it will go like this. Suppose this is my a2, then this is my a3, this is my a4, this is my a5, a6, a7, like this. It will increase, it will go beyond infinity. Similarly, if it is monotonically decreasing, I am drawing in red color. This is my a1, it will decrease. Suppose a2, a3, a4, a5, a6, a7, a8. Suppose this is a9. This is monotonically decreasing. Is it clear, the diagram? So can I say this monotonically increasing sequence is bounded below? Because not a single term is going beyond this. Okay, so I can say this is the infimum. A1 is the infimum, means it is bounded below. Bounded below. Similarly, I can say this A1 is the supremum for monotonically decreasing sequence. So I can say my monotonically decreasing sequence is bounded above. But our focus is whether is when this sequence will be convergent or divergent. Let's see here. Here my sequence is increasing. It will increase to infinity. Means it is not bounded above. It is not bounded above. That means my sequence is unbounded. My sequence is unbounded, and we learned yesterday if it is unbounded, it will be definitely divergent. The same thing for monotonically decreasing sequence. If it is bounded above, but it is not bounded below. So my sequence is unbounded. Unbounded implies divergent. So this is the general case. But what will happen if I make the sequence bounded above? If I make this monotonically increasing sequence as bounded above, means I am fixing this line. Means I am saying my sequence is bounded above by this, or this is my supremum. Let's say A is the supremum for this monotonically increasing sequence. Means for understanding, I am giving you a better example. There was a teacher who was very lazy. Lazy in the form of means he does not check all copy. What he did, he checked just suppose in there is a semester exam. The semester exam was of 30 mark. There was 5 question, each question 6 mark. And what the teacher decided, he decided I will check only first number, and whatever the guy will score in the first, I will give the mark by increasing 1 in the next onwards. Suppose in first question one guy scored 4 mark or 3 mark. So second question how much will give? 4. Third question how much will give? 5. In fourth question how much will give? 6. In fifth question how much will give? He can't give 7 because every question's maximum mark is 6. So he have to again give 6. So this is monotonically increasing, but this is bounded above. It can't go beyond 6. In the similar fashion, I did here, my sequence is monotonically increasing, but I put the limit. I put the limit means my sequence will not go beyond this. Means then how it will happen? It will go like this, then it will not go beyond this. Means it will continue up to infinity. And if I decide, if I make a infimum, if I make a infimum for this monotonical decreasing sequence, then my sequence is suppose like this. It will go like this up to infinity because it will not go beyond this. This is my A. This is my infimum. And here I assumed A is my supremum. I defined A is my supremum. Then by seeing the diagram, you can say this sequence will be convergent. Suppose this is my M. After all n greater than equal to M, all the terms in the sequence is A. That means my sequence will be convergent to A. It is clear from the diagram. Same here. Suppose this is my M. After all n greater than equal to M, my all terms are A only. That means my sequence will be convergent to A. After all n greater than equal to M. Understood? I explained you by through example, but we will prove it mathematically. Okay. So what will happen? See here. So when monotonically increasing, monotonically increasing bounded above sequence. If my sequence is monotonically increasing and bounded above, then it is convergent. Just now I explained. And for this monotonically decreasing, if it is monotonically decreasing and as well as bounded below, then my sequence is convergent. Understood? Now we will prove it mathematically. And of course I will prove only one. You have to try another one because both are similar. So what will I prove? Every monotonically increasing bounded above sequence is convergent. Every monotonically, I am not writing question again, I am just telling every monotonically increasing bounded above sequence will converge it to its supremum. Here it, in the case that was converging to A, what was A? A was supremum. Here A was infimum, it was converging to infimum. Let's say I have to prove, let A and be my sequence. Let A and be my sequence. That is given, it is monotonically increasing. That means A1 is less than equal to A2, less than equal to A3, like this. Okay. And I have to prove this sequence will convergent to its supremum. What is A? A is the supremum of this sequence. Supremum of An. What is N? An is any natural number. Is it clear? I have to prove my An will convergent to A. So for proving any sequence is convergent, what is the first step? Any blind person can also tell. I have to assume epsilon. Let epsilon is greater than 0. Yes. So can I write A minus epsilon is less than A? Because epsilon is positive real number. If I subtract anything from this, then it will be definitely less than this. And see, what is A? A is the least upper bound or supremum. A is the least upper bound or supremum. Suppose this is my sequence, this is my A. And if the sequence will be converged, means I have to prove all the terms after n greater than equal to m, all the terms after all n greater than equal to m should lies between this. See here, A is the least upper bound. Do you think A minus epsilon is the upper bound? No, because it is the least one. So A minus epsilon can't be the least upper bound. Can't be a upper bound. So least upper bound, what will? So A is my least upper bound. This can't be. So if my sequence is convergent, all the terms should lies here and here. But as A is the least upper bound, not a single term will lies here. Because it is the upper bound of the sequence. All the terms are less than that. Or less or equal to that. So all the terms will lies here. So I have to choose such M. I have to choose such that my a minus epsilon is less than am is less than a. Okay. And as it is monotonically increasing sequence, can I write am is less than equal to am plus 1, which is less than equal to am plus 2, like this, and it is also less than a minus epsilon. Can I write it is less than a, as a is the least upper bound, it is upper bound of the sequence, every term should be less or equal to this. I can also write it is less than a plus epsilon. See here, can I write my am is lying between a minus epsilon to a plus epsilon? In the same fashion, am plus 1 is also belongs to a minus epsilon to a plus epsilon. Similarly, you can write many, means am plus 2, am plus 3, am plus 4 up to infinity. So in short, I am writing my am is lying between a minus infinity to a plus infinity for all m greater than equal to m. Proved. That means my sequence is convergent to its, my sequence converges to its supremum. And same for monotonically decreasing. Here I took a minus epsilon less than a. In that case, you have to take a plus epsilon is greater than a, and you can prove. It is task for you. Just try. Okay. So this is all things, the basic things. So now I am going to memorize some childhood. But sometimes childhood memory gives pleasure. But I will tell something that will not give you pleasure. So when we are studying, means in childhood, what we learn first? In mathematics, as I am teaching mathematics, we first learn about numbers. First we learn about numbers. Means 1 to 100. If we learn more 200, 300, learn anything. But just after completion, our elders, our parents, our teachers make us learn addition, learn subtraction, learn multiplication, many things. For the all things, we means for the all things, if all things are sequence, we are the limit of the sequence. Means our parents, teachers never left outside of this interval m minus epsilon to a plus epsilon. Means what I mean to say, means after studying all, we learned about addition, subtraction, these things. So now we will deal with those things. If we add two convergent sequence, if we subtract two convergent sequence, then what will happen? And also we will consider if we add two convergent and one convergent, another divergent, what will happen? So first consider, I am considering two sequence. Let xn is a convergent sequence, it is converging to x. Yn is a convergent sequence, it is convergent to y. So first thing I am writing, if I add two sequence means xn plus yn, it will converge to x plus y. How? I can prove in short. I have to prove this one. That means I have to prove xn plus yn minus x plus y, it should be less than epsilon. I have to prove this. Okay. So can I write like this? Xn minus x plus yn minus y. See, this is my a, this is my b. Mod of a plus b is less than equal to mod of a plus mod of b. Yes, what is my a here? Xn minus x. What is my b here? Yn minus y. Since it is convergent, I can write, since it is convergent, I can write this is less than epsilon by 2. This is also convergent, I can write this is less than epsilon by 2. And some people may think, why I took epsilon by 2? I was always taking epsilon, but this should be positive number. It is not always epsilon. It is not any rule. But it should be positive only. If epsilon is positive, epsilon by 2 is also positive. Na? But based on our purpose, we have to use. We can use either epsilon by 2, epsilon by 5, epsilon by 3 like this. So, but I need here, it should be less than epsilon. If I took this is epsilon by 2 plus epsilon by 2, then only I can get this is less than epsilon. Proved. Understood? Why did I take epsilon by 2? So this proof is easy. I am not going to do the another proof. The other proof, my sequence xn minus yn will converge to x minus y. Similarly, xn yn will converge to xy. And based on this property, you already solved limit problems during your intermediate. If I multiply any real number, Cxn, it will convert to C. What is C? C is any real number. Similar fashion, xn minus xn divided by yn will convert to x by y, subject to my yn should not be 0 for all n and y should not be 0. Okay, so these things you know, just simple things. You can try these proofs, but I am not going to prove all things. I just show you one, then do yourself. Now consider. You understand? If you add two convergent, it will be convergent. Means whatever you do with two convergent sequence, it will come convergent. If you divide, then you have to follow this condition. Now let us speak about what will happen if I add a convergent sequence with a divergent sequence. What will happen? If I add a convergent and divergent, it will be divergent. How? I have to prove na. Suppose an be a convergent sequence, bn is be a divergent sequence. So what will be the sum an plus bn? I am saying this is divergent. I am saying this is divergent. Don't follow me. Okay, let's assume this is convergent. Assume this is convergent. This is my convergent. This is my divergent. So what will happen if I subtract two convergent sequence? Here see, if I subtract two convergent sequence, it is convergent. Of course, it is convergent to x minus y. It will converge to another number, but it will converge. So if this is convergent, I am assuming this is convergent. This is convergent. Then if I subtract, then it will also convergent. Na? If we subtract, what will you get? Bn. But what is Bn? Bn is divergent, which is contradicting our assumption. That means whatever we assume, that is incorrect. Means an plus Bn is a divergent. Understood? Now let us add two divergent sequence. If you add two divergent sequence, it may be convergent, may be divergent. For example, if we take 1 minus 1, 1 minus 1, 1 sequence, another is the 1 minus 1, 1 minus 1. If you add, you will get 2 minus 2, 2 minus 2, which is also divergent. But if I will take the sequence like this, 1 minus 1, 1 minus 1, another is the minus 1, 1, minus 1, 1. And if I will add, I will get 0, 0, 0, 0 like this, which is the constant sequence. Means it will converge to 0. So if you add two divergent sequence, it may be convergent, may be divergent. And if you multiply two divergent sequence, you may get convergent or divergent. You may take example any of your own, like this I can take. For example, just take the same example. One is 1 minus 1, 1 minus 1. Another is the minus 1, 1, minus 1, 1. Sorry, these two. Take this pair, take this pair, you can get. And here both should be convergent. But if I took one divergent sequence like 1, 2, 3, 4 like this, another maybe 1 minus 1, 1 minus 1, both are divergent. But if you multiply, what will you get? 1 minus 2, 3 minus 4, which is divergent. Understood? I hope all things get clear to you today. So we will meet in the next class. Till then, goodbye. Tata. Thank you.